Okay, now we will prove the first equation of circular motion, that is your omega is equal to omega naught plus alpha t. Now for that, what we do, let us consider a circular motion, which is taking place about, sorry, yes, about center O. Circular motion is taking place in a circular part of, say, radius r. Suppose this is the first point A and this is the point B. Okay, so what we will assume that, let while at A, omega naught be the initial angular velocity of a particle undergoing circular motion, and while it reaches the point B, it increases to what? Omega, and for that how much time you require? T. Okay. Now, so since angular acceleration angular velocity increases, so there must be angular acceleration. So your angular acceleration in terms of differential calculus will be equal to what? That is a what? D omega by dt. So d omega will be equal to what? D omega will be equal to what? Alpha into dt. Now we are going to integrate equation 1 within proper limit. So we will what? We will integrate equation 1. So we will write integrating 1 within proper limit. Okay, so it will be like this, that integration of d omega. Okay, now on the right hand side, integration of what? Alpha dt. Now the question is that how you will select your limit. What will be your initial limit and what will be your final limit? Okay, now you see the variable is omega here and variable is t here. Now this is what? This is the initial case. So if it is initial case, so I can take t is equal to 0. At t is equal to 0, what is the angular velocity? Omega naught. So this is how limit are selected. And this is the final position, and which actually achieved after time t. So that means final time will be what? T. And at that time, what will be angular velocity? Omega. Okay. So what is the formula of integration? X to the power n dx. So the result will be what? X to the power n plus 1 divided by what? N plus 1. Now here only d omega is there. Actually d omega is there means what? There is omega to the power 0, because anything to the power 0 is equal to what? 1. So according to this formula, I should write as what? 0 plus 1. It should be 0 plus 1. It should be okay. It should be 0 plus 1 divided by what? 0 plus 1. Then, yes, upper limit and lower limit. Alpha is constant, so we take it out. So in case of dt also, no t is there, that means t to the power 0 is present. So according to the formula, it should be like this. It should be like this. And upper limit will be this and lower limit will be this. So we will have what? Omega, upper limit, lower limit. And this is what? Alpha t, upper limit and lower limit. Okay, now if you put down the limit, then you will have what? This omega minus omega naught. So you will have what? Omega minus omega naught. And on the right hand side, you will have what? Alpha t minus 0. And finally, you can write what? Omega is equal to what? Omega naught plus what? Alpha into t. And this is your what? So this is your first equation of circular motion.